Thank you so much, everyone, for tuning in. It's been now a few months since Potion Unlock, and we just wanted to spend some time to give you a product update, to share with you the progress we have made since and kind of the overall direction that we are taking the development into. So this is the agenda for today. We're going to start with a quick recap, just zooming out and looking at where we are in the context of our journey as a project and as a team. Then we will actually spend the bulk of the time going into the progress we've made in development, and we'll look at this from the angle of smart contracts, the front end, analytics, and so on. And then we're also going to spend some time talking about what's next from here on out. So we've now been together as a team for over 2 years. And just to remind everyone, we started just as a hackathon submission. Then we were lucky to attract some really sophisticated investors from the DeFi world before we were able to complete the development on a set of smart contracts. Then we actually had to come up with a new set of smart contracts to actually release the IP into the world. That was Potion Unlock. And now we're beginning a new development cycle. So we're now beginning a new set of contracts that we're calling the Potion Hedging Vault. And today we're going to be talking a lot about it and explaining how it works. But I just wanted to make a quick comment here. I know that we've been quiet. Part of it is for regulatory reasons. We were very serious about not crossing the line, regulatorily speaking. And for that reason, we try to stay away from any community and keep just heads down on development. But also, Unlock was very intense. You know, it was a big milestone for us as a team. And I'm happy to say that the team actually not only survived the emotional experience, but actually strengthened. And I think we're now feeling very solid as a team. And we just remain as excited as we ever were about the future of the project, which, to be clear, is all about democratizing risk management through Web3 public goods. We really believe we're doing something meaningful. We're creating something that can be useful for many people, that this is valuable research. And so none of that has changed for us in our minds. And so actually, let's get into the product itself and what we're working on, which is really exciting. And before we get into it, maybe it makes sense to start with Potion AMM, which was the initial product. And the big idea for that product was, if you want to create a risk management system, it kind of needs to start by protecting the people that are contributing cash to it. And these are the LPs. So when we designed the AMM contracts, we wanted to make it flexible for the buyers, and there are a lot of nice features for the buyers. But fundamentally, the thing that we were most concerned with was how sustainable is the system. And in the end, we found that the answer to that sustainability problem is using the mathematics of the Kelly criterion, which basically optimize for the growth rate of the LP and find premiums that give you a positive expectation of growth rate. So this time around, we're actually focusing our energy in creating a new set of smart contracts that are focused on the buy side. They're focused on the person buying insurance. Okay, we want to make the life of this person as simple as possible. And so for clarity, this is not a new version of the prior contracts. This is a brand new set of contracts that complement the existing product. And the idea here is to automate the purchase of insurance. That's the big hurdle that we're trying to overcome with a really simple goal, which is to allow people to manage their risk very simply. You know, I just put an asset, for example, Ethereum, and then the contract is going to be buying the put options that are required to provide the protection that the user required. So you don't need to be like a derivatives trader, you can just be a normal person and make very simple choices, right? For example, maybe you just want to be protected against black swans, or you want to have an idea for what's the maximum drawdown that you can afford, right? And set that very clearly. And this, not only is it something that excites us because that's really what we wanted to build to begin with, we wanted to be able to cover our assets, it's actually something that creates and aggregates demand for the existing set of contracts. So it feels like a really nice rounded way that completes our idea for how can you do risk management simply with the new set of Web3 tools. And so speaking of risk management, I wanted to start giving you a hint for the types of risk management strategies that you can implement with these contracts. And we're going to be going into a lot of technical detail, but let me try to explain at the highest level what we're talking about when we talk about risk management, you know? So let's start with this figure, which is, I think, perhaps the simplest. This is what happens when you have, for example, one ETH and you buy one put option for that ETH. That's the resulting payoff function. So when you have the asset and protection on the asset, what you are able to is to participate from the upside. So when Ethereum is aggregating, you participate from that upside. But crucially, because you have some put options as well, you're actually not participating from all the downside. You have some downside because you have to spend some premium, okay? And that's the basic idea here. Maybe I don't want to lose more than 10%. So I just buy this put option and I know for a fact that if Ethereum goes up, I will benefit, but if it goes below 10%, I am protected, okay? And this, by the way, is called a synthetic call, right? And we think it's quite cool that you can opt into a contract and say, can you please apply a synthetic call strategy to my asset? And you make that a one-click, so it's like a one-time decision, and then the contract automates the recreation of that payoff for you. That feels like something I would want, at least, you know, like this is going to be implemented in Web3, and we're working towards it. So you can actually also play with the ratio, right? So for example, if you still have one ETH, but instead of one put option, you actually buy two put options, then you end up with a different payoff shape. You still participate from the upside, but now because you actually bought more insurance that was required, not only are you canceling the downside, you actually start participating from the downside in winning terms. We call this like an anti-fragile position. You know, you actually gain strength in market weakness, which is interesting for some people. You can also think of it as volatility harvesting. So if the market is very, very jittery, it doesn't matter if it's going to go up very much or down very much. You just want that it goes very much in either direction. Also quite interesting to be able to get into this type of strategy and be there, and temporarily perhaps, maybe there are events. I mean, now we have the ETH merge coming. It feels like, that's the type of event where you might want to put yourself in something like this, If it kind of explodes up, you participate, and if it fails, you're protected. Not only protected, you actually benefit from the downside. So very interesting strategy that for most people feels not accessible, that hopefully with the Hedging Vault now becomes possible. And then finally, you can actually do the opposite. Instead of over covering your position, you can undercover it. So maybe you can buy half a put for every ETH that you have. And then you end up with something that is less protective than this. You participate from the downside significantly, but less so. And the benefit of this is that this is less expensive. So if, for example, you're in a bull market and you think that the risk of a downturn is low, then maybe you say, let's actually save the premium. I want to spend a little bit less because I'm confident that it is unlikely, and I want to maximize the growth. Let me show kind of how the user experience for something like this would be like. So here in this section, you would see kind of the assets that you currently have risk managed. So these are the pools in which you have already invested. And then you would have here other choices, maybe other types of risk or other assets. And the idea here would be that the users would be able to choose between different products, like we just said, different durations. So for clarity, this product is cyclical. So it means that this risk management lasts for a certain time. And it can be weekly or monthly or bi-weekly. It can actually be configured in any duration. And then the impact to the user is that if you're, for example, on a monthly pool, then when you signal withdrawal, it may take up to a month before that withdrawal takes place. If you kind of are more time sensitive or want to be able to withdraw quicker, then you just want to go on a weekly window. And then at most, if you wanted to withdraw almost immediately after you come in, you just signal, and then it will take 1 week for your funds to be available. And the trade-off here is that the longer duration, the lower the premium. So it's cheaper to get into a 1 month cover than to buy 4 weeks of cover. And so that's kind of just a quick sneak peek into kind of the product vision. Let me hand over to Guillem, that is going to go into what does this look like in terms of architecture and smart contracts.
Hey there, I'm Guillem, the CTO of Entropical Apps. You know me from previous calls. I'm now going to walk you through the progress we've been making from the smart contract side of the Hedging Vault product. I'll start with a very quick recap on how the basic Potion protocol works. You have these two opposing players, the liquidity provider and the buyer or liquidity consumer. Assuming the LP has previously deposited some liquidity in a Potion pool, the buyer can start an option contract anytime by sending the correct premium to the LP pool. The collateral associated with the option is segregated into the escrow open contract, where it stays until expiration. At expiration, the contract is settled by a Chainlink oracle, and if the price went down, the payout goes to the buyer, and if it went up, it goes back to the LP. As easy as that. The problem with this setup, though, is that things are very manual and operationally intensive for the buyer. If the buyer wants to get an asset continually hedged, she will need to purchase one option after the other. So she'll need to send the premium, get some collateral locked, and at expiration retrieve the payout if any, and buy the next potion and so on. That's a lot of transactions, and if she misses some, the buyer risks having assets unhedged. The Hedging Vault solves this problem. So imagine the buyer has some assets to be hedged, say Ethereum. All she needs to do is send those assets to be hedged directly into the vault, and she will get back some shares which will be redeemable whenever she wants to exit her vault position in the future. The vault is going to take care of permanently hedging the deposited assets by automatically buying recurring put options from the Potion protocol, ensuring a hands-off experience to the buyer. So how is the Hedging Vault operating under the hood? It's operating in cycles, basically purchasing a set of put options with fixed expiration at each cycle. This is not immediate though, because the premium for those options needs to be paid in stablecoin, and the payout also comes back in stables. That means that the first step of the cycle must be to swap part of the deposited assets for stables, say swapping ETH for USDC through Uniswap. Then that USDC can go as premiums to the Potion protocol, and the vault can get back some potions. At expiration, the potions are exercised, payouts are received in USDC into the vault, and are swapped back to ETH, the original hedged asset, using Uniswap again. If payouts are larger than the premiums spent, the vault increases in size in terms of the hedged asset. So as we can see here, the vault now has more ETH because the price went significantly down. This would end the cycle and allow a new one to begin. Another important question regarding the Hedging Vault is, who is operating it? Who is in charge of triggering these cycles? Since this is a tricky one, we decided to tackle it in two progressive iterations or stages of development. In the first stage, which is the MVP that by the way is already developed, the vault is manually operated by a privileged address, the operator. This manual operator needs to trigger two transactions in order to complete the cycle. First one, premiums are liquidated, sent to purchase options. Second one, the potions are exercised, payouts are swapped back. In the next stage, we're developing an automated operator that will just need to trigger one single transaction to get to the next cycle. And in addition, we're looking into making this operation securely open to anyone by introducing some measures of anti-tampering kind of mechanisms. Finally, I want to highlight another crucial aspect of the hedging vault architecture, and this is the actions pattern. Actions can be thought of as composable templates or macros for conducting particular on-chain activities, such as buying put options, as I've been explaining so far, but also other stuff such as shorting the assets, staking them, lending, borrowing, etc. This allows our vaults to implement all kinds of hedging strategies from the get-go, from protective puts, synthetic straddles, gamma scalping, etc. New actions can be modularly added to the hedging vault to trim it to a particular use case. So with that, I hope you get a rough idea of how the hedging vault contract works. When designing its architecture, we've been following these three main principles. First, we've been doing extensive research for months on other related vault code bases existing right now in DeFi. Main sources of inspiration were the ERC 4626 standard, the Ribbon B2 Theta Vault codebase, and open perpetual vaults. As I explained, we've been focusing also on getting a flexible and customizable design so that we can implement all sorts of options, hedging, and other investment strategies with our vaults. And finally, we wanted our architecture to minimize trust as much as possible, because we think this is one of the problems that other vaults out there have currently. And to finish, I wanted to mention that given our level of experience acquired so far, we've been committing a lot of effort in product and development planning. So instead of going for a fully fledged product directly, we wanted to commit to small steps and iterations. For this, we have carefully prepared a detailed roadmap with several increasing features that will lead us to the final product. We're excited to announce that we've currently passed the MVP phase, and we expect to reach the final product in the next few months. That's all for now. I'm handing over to analytics guys, so thank you all.
Thank you so much, Guillem. So now I want to switch gears and talk about the progress that we have made around analytics. And so as a quick recap, you can think of analytics as a simple black box, which by the way is open source, and you can actually go into the code if you want to, but that allows you to put in some input data, for example, an information model, a strike configuration, the amount of hedging you're doing, the cycling, utilization, the market pricing, and so on. Run some random scenarios that are in keeping with the information model, and then observe and illustrate what are the experienced performance of a number of players in the market, in this simulated market. And in this case, we're looking at what's the return or compound annual growth rate. How much is my capital growing, compounding by? And we're also taking a measure of risk in the form of the maximum drawdown. And in the past, we were only looking at the LP and the hodler. And on this version, we're adding the hedger. So now we're monitoring in the simulated market what the hedger, the hodler, and the LP are getting returned and what risk they're facing. And the hope with this is that this tool can help LPs make decisions about which bonding curves to use, because they can try a bonding curve and see return and drawdown, and if they don't like it, they can keep changing their bonding curve until they get the result they want. Now we're lighting up the parameters such that the hedgers can do the same. And we're working on two separate branches. We have an Excel branch that is useful for fast prototyping, and we feel is more digestible and will allow people to look under the hood without having to have programming skills. If you're good in Excel, you're able to see our logic, and we're actually really proud that our logic is simple enough that you can program it in Excel. But then for more scalability and also extensibility options, like for example connecting the simulator to the actual logic of the smart contracts, then we're also developing a Python branch. And today we're going to be doing two quick sneak peeks, and we're going to be looking into both of them. And I'm going to be starting with a quick demo of the Excel branch. And I hope that we have more time on another occasion to go deep into the simulator. But for now, we just want to illustrate what's the experience a hedger would get when applying this type of strategy, which is the simplest strategy. That's the synthetic call strategy, which is basically buying one put option for every one asset underlying, okay? And we're going to go through the simulation now, but these are the big ideas that we're trying to illustrate. The first is that relative to a hodler, you're giving up CAGR, and we can tell that the hodler would have the line crossing at 0 because we're paying a premium here. Even though we are participating from the upside, we're taking a hit in the CAGR. And then we also want to illustrate that because on the downside, here I have insurance, I should get better drawdowns than just a pure hodler. And then finally, we will try to illustrate what happens when a black swan happens in the market, something that nobody's expecting suddenly happens. We'll compare how the hodler looks like relative to the hedger. So let me change the screen into Excel. And this is the dashboard for the new version that we're working on. You have a number of parameters here. I'm not going to go into them now in the interest of time. I just want to leave you with a couple of intuitions. So here you can see the payout functions for the 3 players that we're monitoring. The LP, which is the purple line and purple color across the dashboard. The hedger, which is the yellow color across all the charts. And then the hodler. The hodler is the benchmark. Here you can see the bonding curve that our tools are suggesting for these parameters. And in the yellow dot, you can see the particular utilization and premium that the simulator is currently assuming. Here you have some information about the information model. So in the background, you have the historical Ethereum histogram, and then overlaid, you have what is actually being simulated. And we're just trying to make sure that we are producing random paths that are in keeping with Ethereum. And you can see that while there is some fluctuation, for the most part, especially on the percentiles, things are pretty steady. And then here, what you're looking at is a one simulation. So over the x-axis, you have the time, and then on the y-axis, you have the performance or the return, right? So here is the 100, right in the middle. And here, I just want to get like a basic intuition for how are people doing. So I can see the line of the LP seems to be doing okay. And notice what happens if I actually lower the premium. So notice that I'm now going below the bonding curve, and look at the return paths. Each of these is a random simulation, but I can see that the LP is kind of not having a good time. And now let me choose a premium that is way above the bonding curve. Now the hedger seems to be kind of paying so much premium that there is no chance for them to be making money. So it seems like there is like a balanced premium that is high enough for the LP to more often than not make a profit, and for the hedger to be in kind of the same middle ground. And all the Kelly criterion stuff that we do helps us find this premium. But now I just want to go into illustrating these phenomena for the difference in performance between hedgers and hodlers for, in this case, a synthetic call. So every time I run a simulation, I get a new result. And then what I'm going to do now is I'm going to, instead of running one at a time, I'm going to run 100 simulations at a time, okay? And then for each simulation, I'm going to keep a track of what's the return after 1 year. So I'm going to look at the return of the hedger, the return of the hodler, and the return of the LP. And that's what each of these dots is going to represent. So let me run the simulation. You can see here. And now I have here a summary of 100 runs. And I can already visually get some intuitions. So in green, I have the hodler. And I can see that the yellow, which is the hedger, is kind of shifted right. And then I can see that the LP is actually the one that has the best, the kind of the most right performance. Here, by the way, we have the risk, and here we have the CAGR. So when we're moving right on this chart, we're actually seeing that we have lower drawdowns. And where we're going up on the vertical axis, then we have better CAGR returns. On this chart below, you're seeing the information specifically for the drawdown. And you can see clearly that if you look at, this is the distribution of drawdowns for the hodler. So how frequent each of these 100 results are from a risk perspective. And you can see that 95% losses are infrequent, but that the most frequent drawdown is around 65%. Notice how the hedger, the dots in yellow, is shifted right. It means that now 95% becomes impossible, that there is zero frequency for that result, and that we start having more and more frequency, but that kind of the more frequent result is actually 30% drawdown. Compare this, right? This guy is getting a 65% drawdown is the most frequent result. By hedging, I'm able to manage my drawdowns. What is the catch? The catch is the CAGR. So notice how here there are a lot of people like in these simulations, the hodlers are doing really good. So the more frequent result is actually more than 200% returns. So notice how for the yellow dots, it's kind of shifted left. So that was the first intuition that we wanted to land, right? That we are giving up CAGR, but that we are getting better drawdowns. And now I'm going to simulate a black swan. I'm going to look at what happens if there is a black swan happening. And for this, I'm going to assume that there is a 80% drawdown, and I'm going to say that this is in cycle 10. So now notice that while these paths are all random and my simulator is still kind of doing reasonably close, now I'm manually forcing a black swan, and that black swan is always happening at the same point in time. So now I'm going to run 100 simulations once again and try to keep in mind this result. Whoa, you can tell that this looks very, very different. You can see now that the yellow dots, the dots that represent the hedger, are significantly more to the right. And not only that, but they're actually significantly up. So when a black swan happens, not only are you overperforming in terms of drawdowns, but you're massively overperforming also in return. And that's because the guys here that are suffering the 80% loss, they're going to have a hard time clawing back and recovering that loss. Whereas, I mean, you can actually see it here visually on the yellow line. So the yellow line, when the drop happens, doesn't notice it, right? Because it's hedged. Because that player is hedged, they don't notice the drop. And that allows them to grow from there. And when you run it many times, that's the picture that you see. The other example I wanted to show was what happens in a straddle. And let's actually configure the simulator for a straddle. So now I'm going to change the hedging rate. So now I'm going to go 200%. So this means that for every unit of underlying that I hold, I'm going to be buying 2 put options, 2 insurance contracts. And the result of that is that I now will have gains. If the market drops very significantly, I now have an expectation of profit on both sides. And the price that I'm paying is that if the market doesn't move much, then I'm going to be paying a higher premium. So let's, for now, remove the black swan, and I'm just going to run a few. So we don't have the black swan anymore. Let's look at how the performance looks like. So now you can see that the hedger still has better drawdowns. Like if I look at the drawdown picture, I can see that it's shifted left, but I can see that I'm taking a much bigger impact on CAGR. If you will remember the prior chart, the yellow line here was kind of going up. You had a fair amount of samples where the returns were over 200%. Now, most of the samples are between -80, -70%, and 200%. So I'm taking a higher hit on CAGR, that's because I'm having to pay more premium, right? Because I'm having to buy twice as many insurance. So now let's assume there is a black swan in cycle 10, like we did before. And I'm going to run a 100 simulation. And again, notice how we're seeing significant shifting to the right of the drawdowns. And now notice how the CAGR is for the most part positive. So we're now going higher up on the CAGR scale. You can see the drawdowns here being completely different to the ones of the hodler. This guy is very much to the right. And same idea on the CAGR, I have a very significant overperformance, even more so than before. And so hopefully this illustrates the idea that when I'm actually opting for a straddle, which has this shape, then I'm giving up more CAGR, but I'm getting even better drawdowns than before. And in particular, if a black swan happens, I'm getting massive, massive returns. And so with this, I'm finishing up my section, and I want to hand over to Mike that is going to go into the Python branch. Over to you, Mike.
Hey, thanks, Jordi. For those of you who don't know me, my name's Mike, and I'm going to tell you guys today about the Python side of the analytics tools. So just to talk about some of the high-level stuff for intuitions with hedging with puts, right? So generally, when you buy puts to hedge against something that you're holding, you're going to be fighting against the time decay of the put, because eventually it will expire and you'll have to buy a new one if you want to keep hedging. And so that means that as a result of that, if there's a drop in price soon after purchasing the put, that actually makes the hedging strategy more profitable if the drop in price was going to happen anyway. And in general, with the time decay, the way that it works, it's very nonlinear. And so when you buy one put that's a very long duration, that's usually much cheaper than repeatedly buying a short duration one. So if you buy a 1 year put one time, that's going to be way cheaper than buying hundreds of 1 day puts. And so in general, when you buy puts, you're hedging and you're trading your upside return for protection on the downside. And if the asset's volatile, then that could be beneficial to your strategy. Then because you can protect yourself and your investment. So just in general, it's helpful to get an idea of how the puts and the calls are related. So there's something called a synthetic call, and that is when you hold some underlying, like a stock or a crypto or something, your payoff's just a straight line. You can see that on this graph here. And when you buy the put for protection, that has a payoff that looks like this. From the strike price, afterwards the put starts paying out, and it cancels out the losses that would have happened if you were just holding the underlying. And so the resulting is this solid line here, which the payoff is just like buying a call would be. So by combining the long position in the asset with the put, you get the payoff of the call. And that happens if you buy them in equal quantities. The strike price of the put would be setting the strike price of the call that you were purchasing. So there's some advantages and disadvantages, just like with anything, right? And so one nice thing is that it covers your underlying position, and you get the same exact payoff as the call without having a taxable event on the underlying. So depending on what jurisdiction you live in, like for the US example, like if you were to buy the call and have it expire, right, that might be a taxable event, whereas you might have to pay any taxes on the put payouts, but if you were just holding the underlying for a long period of time, potentially you wouldn't have any tax until you sold it sometime far off in the future. So you can get the same payoff as buying the calls, but potentially doing it more efficiently that way. And another advantage is that if the underlying has any staking rewards, like say the underlying was Ethereum and you switched it into staked Ethereum, you could collect those staking rewards from holding the underlying while you're doing this, and those wouldn't necessarily be paid out if you were to buy a call. And then of course, the underlying never expires. And so one thing to consider also, there's a thing, right, in this situation, we're looking at buying the we're looking at buying the underlying and the puts in equal amounts. And so that gives you the exact payout of a call, right? And so there's something called the hedge ratio, which is the ratio of the number of shares of the underlying versus the number of puts. And when they're 1-1, it's a synthetic call, but you could buy more puts or more of the underlying and change the slope of this part on the bottom here. So in our analytics tools that are showing the hedging vault, you can control what that ratio is, right? And so this is just a plot showing the payouts of all of the people in the simulation. And so the simulation has three people, the hedger, the LP who is selling the puts, and the holder, and just as a reference for if you were just holding the underlying over time, right? And so the payoff for the LP is this red one from selling the put. And we did a lot of work doing the analytics for that before the unlock event. And so the hedger here is the yellow line from buying the put from the LP and combining with holding the underlying, right? And so, it's a synthetic call or married put if you do it in equal amounts. And the payoff for the hedger is going to be shifted downward because you're spending that premium. So that's where you're trading the upside in exchange for this protection from downside risk. And if you play with the ratio, you can have the line be sloped differently, right? And so that's something that can be controlled by the user. You can have more or less protection than the synthetic call. And as always, there's a balance between how much you're spending on premium and how much you're getting for protection, right? And so that's a trade-off that anyone who wants to run simulations would have to make. And in general, these analytics tools are in Python. So it's got a Jupyter Notebook front end. And what's nice about the Python tools is that they're very extensible and customizable. So you can hook them into your own Python code, and it scales to a ton of paths and high-intensity simulations because there's Excel's a great tool for prototyping, and you can do stuff very quickly and see things visually, which is fantastic. But sometimes it has limitations, and it's nice to be able to take out the big guns if you want to put in the extra work of working with Python. So this plot is just showing a demo of a simulated run with a bunch of different price paths with the three of them. So you can see the LP performance. On the x-axis we have their drawdown, and on the y-axis the CAGR, right? And so for the LP, because of the Kelly criterion, they have positive expected CAGR there, and the drawdowns are generally very few. And you can see over here the holder, the underlying versus the hedger. And you can see, sure enough, the hedger here is trading some of the upside here for reduced drawdowns on the x-axis here. So, it shows our intuition that we had for the simulations. And in in general, the tools will allow you to compare some of the LP stuff to the buy side now. So just talking about the roadmap that we are dreaming of for some of these tools, right now we're focused on a little bit of the proof of concept. So we want to compare the results to the LP simulations and verify that the Kelly criterion behavior is working in a bit of an ideal simulation, just so we can compare apples to apples with the LP and demo some of the basic concepts and intuitions of hedging with puts. But the long-term roadmap, we want to make these tools useful for looking at real-world scenarios. And a lot of times there's things that you have to consider that are corner cases of dealing with the real world, like maybe there's execution troubles with something happening on chain in the simulation, like maybe the LP state changes after the transaction already started. Maybe in the simulation, one of the counterparties could run out of funds, or there could be deposits and withdrawals. Simulating things with gas fees and routing and stuff like that. These are all real world problems that someone who was using the on-chain stuff would have to deal with. And so the simulation, we would like to have eventually address that. And so one of the things also we wanted to look at for improving confidence in the tools is to connect the Python analytics tools to Ganache, because you could test it with the live, or the simulated smart contracts, but in the real smart contract code to see if any of these corner cases or unexpected things happen with that, and just if they match just the Python only simulations, you'll know, okay, when you run the Python things, that's already matching what was happening in the smart contract code. So it's all exciting stuff, and hoping to do some of that as we go forward into the future. So now I'm going to switch over to demoing some of the stuff from the Jupyter Notebook. The simulation in this notebook is just hedging a constant percentage of the buyer's portfolio, and it's also at the same time keeping the util that is the amount of capital used by the LP as a constant value. So in this case, it's just doing that to compare it apples to apples against some of the LP simulations that we did before the unlock event, to show that everything's working correctly, right? But at the beginning of the notebook here, you do, of course, just importing all of the Python packages that you need. And this bit at the beginning lets you control all the settings. So, whether you want to fit your probability distribution from the historical data, or whether you want to specify a theoretical one, or play around with different kinds that you want to play with. You can set all that stuff in the beginning, set all the parameters. Here is going to let you control how many price paths get generated during the simulation, how long it is, like how many days, and what the price of the underlying is. And here you can control the put, like the strike and expiration, how much money the buyer and the LP has. Here you can choose whether it's going to calculate the curve internally, or whether you're going to paste in a curve that you got from the other analytics tools, like whether you got it from the Kelly.finance website or any of the fat-tailed tools, right? You can paste in the parameters here. And then here it's going to control, what's the LP's util being held constant at, and what's the percentage that you're hedging there, right? So then the notebook goes through and it fits all of the parameters from the historical data. It's printing them out here. It'll generate the price path. And then here it's going to actually run the simulation. And then we'll plot some of the things that are happening. So here it's showing, here's the histogram of 1 day returns that got fit from the data, and here's the PDF that was fit, right? And so this is a graph of the curve that was being used in the simulation. And here it's displaying all the different price paths that were simulated, and it's normalized to 1 being the starting value here. And sure enough, here are the bankrolls of someone that was just holding the underlying. So in this case, it's a simulation using Ethereum and a bunch of simulated Ethereum price paths. Then we're going to look at the bankrolls of the hedger. So they're also buying a put at the same time. The bankrolls of the LP, and in this case, the LP is using the Kelly criterion to doing the betting. So we can see over time, the median of the bankrolls going up. And then these are just graphs of the compound annual growth rate. So of course, for the holder and the hedger, they're all over the place because it'll depend on what the underlying price path is doing for the Ethereum there. And then for the LP, sure enough, the median's converging as the simulation goes on, just like you'd expect from the Kelly formula. Here's some graphs of the max drawdowns as the simulation goes, and again, the white graph here is the median of all these different paths, the hedger, the LP. In this case, the simulation's holding the LP's util constant, so just verifying that over all the price paths that's happening. And the mechanism by which the simulation is doing that is just, it's simulating a whole bunch of deposits and withdrawals so that the LP stays at a constant betting percentage. So you can see the deposit and withdrawals as the simulation goes on. And then here is a graph of the median of everyone's bankroll. And sure enough, because the median price path for Ethereum just fit from the historical data, it's gone up in the past. And so the median goes up in the simulation, and you can see the hedger and the holder there. Here's the LP's median going up. And then if you want to compare it along a specific path, I think this is like path 3 or something like that out of all the 100 that were simulated. And here's the scatter plot that you saw on the slides earlier that we already went over. Here's a density estimation of the scatter plot, a histogram of the CAGRs, and then these plots are plots of the outperformance or underperformance of the hedger versus the holder, and then the same exact thing with the max drawdown. So, just showing off some of the cool plots that can be made with the simulation and how it's all running in Python. You can plug in and play with your own Python code if you want to. So now I am going to pass it over to the front end guys and Simone to show you what's been going on over there.
Hi everyone, I'm Simone. Today I'll show you what we worked on from right after the Potion unlock until now to reach the app version 2. So, during the last year, we collected a bunch of tech debt that we tried to extinguish with this new version. First off, we rewritten the app in Vue 3 using the new composition API. This way the code is way easier to read, to test, and to scale up. We typed everything with TypeScript from components to business logic. We integrated Web3 on board and enabled Wallet Connect and MetaMask, obviously, so the app now can be used in a smartphone, for example. We swapped Webpack for Vue.js to have faster builds and faster reloading while developing. We added Storybook for component testing, for component development and visual testing, and we added A18N to support multiple languages in the app. Last thing, we ported the whole protocol to a mono-repo orchestrated by NX. The whole reason behind this development cycle is that maintenance and scalability are very important for us to be able to develop new features in fast iterations. And to provide a better development experience is key to engage with the Web3 developers community. So for example, now we have one command to start and the full protocol and start hacking locally. We have shared libraries between the stack. We developed unit tests with vtest. This means that the tests run very, very fast and the setup is very, very simple. We tested every component with Cypress component testing, and we added the GitHub Actions support. This means that you can actually see the component failing in a real browser instance and tackle the bug way faster than when you need to understand what's going on in a log printed in a terminal. Lastly, but not less important, we now have tests running end-to-end every time we push changes to the development branch. What does it mean? With Cypress, we are able to run the app in a real browser and test all the user actions automatically. The tests are developed per user flows. So for example, creating a pool or buying a potion are user flows. The important thing is that now we test the app against the full stack. So the blockchain transactions are real, and we are able to run the tests remotely on demand on GitHub, for example. This is so important for us because like with end-to-end tests, we are sure to not break things in production. Let me show you an example. This is Cypress. It's running locally, the pool creation flow. You can see the test, the inner test, and now the transaction. Now that it ended, I'll switch to the potion creation. And you can see it's loading and running the test on the user flow. That's very powerful. So talking now about the contributions, we helped LimeChain team improving the graph testing framework called Matchstick. And we developed Vue support for the Web3 onboard library. So now you can install and use it already in your projects. Now I want you to show a demo of the Hedging Vault running locally in our machines. We have this UI where the user can check the Vault strategy and deposit and withdraw assets. I'm now depositing one WETH and approving and depositing now. This is a utility page to start and stop the investment cycle during development. You can see that at this stage, the vault has one WETH in. After the vault cycle, the price of WETH went down and the size of the vault is now 78. You can see we have one share. This means that the user can actually withdraw all the vault size, 78 WETH. You can see the redeem is going on, and now the user has 77.49 Ethereum more than before. Thank you for listening. Bye.
Hey there again. I'm going to switch gears now and talk to you about some updates regarding the Entropical Apps team, and also a couple of updates with regards to new partnerships we're currently developing. So beginning with the team update, as you can imagine, Potion Log was a very intense period for our small team in several regards. To begin with, we had to get some new recruits in order to carry on operations related with Unlock. First, we recruited a new smart contract developer, Roberto Cano. Roberto is an incredibly talented technologist with more than 20 years doing software development in a range of areas such as media content streaming and protection, mobile video gaming, blockchain, smart contracts, and generally Web3. Roberto's abilities, both technical and of leadership, have made him grow very rapidly inside Entropica, where he's currently the engineering lead for front-end and smart contracts teams. I would like to take a moment to congratulate and thank you, Roberto, for all the work done and for the exciting work ahead of us. The Unlock operations were also very intense in the backend. We also had to recruit another front-end backend web developer. This was Alessio Buscaini, who helped us massively in many fronts as well. The amazing thing about Alessio is that he came to us with incredible Web2 experiences, but within a few months he has been trained in-house for Web3 by all our engineering team, becoming a master of this stuff. This is a recurring topic, actually. I see many discussions, and in my opinion, it is definitely worth it, investing into training good Web2 developers in-house for a Web3 project right now. But Potion Unlock was also tough and draining for many of us. And unfortunately, we saw a couple of members leaving the team after this experience, but it was in good terms. They went into Snapshot and Oasis app respectively, and we wish them the best of luck and success in their future Web3 adventures. Let me also use a chance to say that we're actively hiring on several positions, so if you are or know of brilliant minds in design, Web3 development, project management, please get in touch. All in all, I'll finish the section saying that I'm super bullish on our whole team right now and how consolidated it's becoming. It's a team of 12. Worth becoming that we assembled physically most part of the team, which is coming from around the world really, during ETH Barcelona. Some of us also had the chance to meet community contributors and investors of the project during ETH City in Paris a few weeks ago. So now on to new partnerships. Firstly, we're talking with several universities in Spain with the intention of funding local scientific research. One of our key goals is to fully expose the basic connection between information theory, the Kelly criterion, and the ability to extract derivative pricing frameworks from it. We believe academic rubber stamping could be highly beneficial here and help generate trust and propel the project. And at a different level, we're excited to have come to an agreement for a collaboration with a renowned branding studio, Mucho. This investment will rehaul our branding and help communicate our vision for Entropic as a pure R&D open source contributor to Web3. And with that, I'm going to hand it to Jordi for the last part of the call.
Thank you so much, Guillem. So that covers the section on our progress on the product. I hope that you guys found it as exciting as we do. And now I just want to close with a few comments on what's next from here. So our first milestone is to complete a prototype across analytics, smart contracts, and front end. That's going to be kind of the minimal viable product. And the idea is to make it available to you guys, people in the community, so that we can run some user feedback workshops and we can get some idea for what are the things that you guys like and what are the things that maybe generate some friction. We will then do a final development push, working towards a release candidate that we will submit for audit, and hopefully we will be in a position to make the code available after that. And then we will get into the bug fixing mode, and probably the next release cycle will begin, always in the direction of trying to make robust, solid risk management products that are available to everybody and that can be used on the new Web3 rails. And so, like I said, if anybody is interested in participating, ping us on Discord, let us know who you are, and we will be adding you to the list. And once again, we're really excited about the release. We very much hope that that you liked the Potion Hedging Vault as much as we do. And we also hope to be able to give you more news, maybe beyond just product, as early as this fall. So once again, guys, thank you so much for tuning in and giving us some of your time, and looking forward to the conversation and feedback on Discord.